So following on from the previous video, we got to this stage here. We got to this stage. We got to this stage here, and then if you select x to be greater than 1, let's say 1.003, then eventually the numerator here will overtake this. It will eventually overtake it. But if you scroll back to the original question, you can select anything, any x greater than 0, meaning you can select a number less than 1. You see, if it's 1.003, if you power it to n, this thing here is going to grow and grow and grow. But then here you are entitled to select a number that's less than 1. Let's say 0.82, say. Now if you power this to n, this number is just going to get smaller and smaller and smaller. This one will grow, will get bigger and bigger. This one here will just get smaller and smaller. So let's go back to where we were before. Let's go back to where we were before. Now, if you select a number here that's bigger than 1, then the whole thing here will grow. But then what happens if you select a number 0.883, say, to the power of n? This thing here will just get smaller and smaller and smaller. And then now this thing here will get smaller and smaller. This thing here will get bigger and bigger and bigger. So in the case of x being smaller than 1, in the case of x being smaller than 1, or maybe equal to 1 as well, this thing here is going to get bigger and bigger, and then this thing here is going to get smaller and smaller. In the case of 1, it will stay the same. But the point here is that in the case of x being less than or equal to 1, this thing here is just going to head towards 0. Now, if you look at the natural log of 0, it's going to head towards infinity. So here you've got infinity over infinity. So it's still indeterminate. In the case of x being greater than 1, this thing here is going to grow and grow and grow. It will eventually overtake the denominator, meaning the whole thing here is heading towards. The whole thing here is getting bigger and bigger and bigger. Now, if you look at the natural log of something that's getting bigger and bigger and bigger, if you look at the natural log of something that gets bigger and bigger and bigger, you are heading towards infinity. So either way, you're heading towards infinity here. You're heading towards negative infinity. Either way, you're going to get infinity over infinity. Either way, it's going to be you're going to get to an indeterminate form. So which means you can apply L'Hopital's rule. So differentiate this. That will then give you this whole thing here. Remember, when you differentiate this, x is fixed. It is the n that's moving about. It is the n that's moving about. If I were to give you, let's say y equals, let's say 7x, say, don't forget this x is different from this x. This is totally different. This one here, dy by dx here, it would be natural log of 7 times 7 to the power of x. That's how you would differentiate it. So the point I'm trying to make is that this is a constant, but in our scenario here, x is a constant. The point here is that when you differentiate this, just remember it is the n that's moving about, and it is the x that's a constant. So when you differentiate this, it will give you this. Yeah, think about it. If you differentiate this, you should know how to differentiate this by now. So differentiate this, it will then give you this thing here. So it's basically, yeah, differentiate it, it will give you this thing here. Okay, so now tidy this thing up. Let me think. So here you've got one thing multiplying another thing here. So if you look at this, this is exactly the same as this. So you can cancel this out with the squared here. You can cancel it out, and then if you look at this here, exactly the same. So so these will cancel out, giving you this. Okay, so if you tidy this up, it will then give you this thing here, and then let me think, and then from here, so here you've got one thing, take away another thing, divided by another thing, divide top and bottom by this thing here. So divide top and bottom by this thing. Hang on. So this bubble will become this, and then you divide it by this. That will then give you this. You've got your 2 your 2, and then you divide it by this, you divide it by this, and then for the denominator, it's going to be this divided by this. It's going to be this divided by this. So so this thing here is going to be 1. So something over 1. We can forget about this thing here. And then as n gets bigger and bigger, as n heads towards infinity, you can see that this is going to become massive. 2 divided by massive is going to head towards 0. And then these two are exactly the same. They cancel each other out, leaving you with just natural log of x. So so after all that, if you tidy this up, it will head towards natural log of x. So the natural log of y equals natural log of x. That can only mean that y equals x. So if y equals x, so the limit is actually x. So so the limit of this whole thing here is actually x. If you can't remember what y was right from the start, we said let this thing here be y. Right from the start. Well, anyway, y equals x, meaning that the limit of this equals x. Okay.